In this video, we're going to cover section 7.4, basic trigonometric equations. So we're going to be given equations with trigonometric functions in them, and we want to solve for our theta value, which is going to be on the inside of our trigonometric function. So our first example here is to solve the equation 2 cosine of theta minus the square root of 3 is equal to 0. So the first thing we can do is solve for cosine of theta here. So we can add root 3 on both sides to get 2 cosine theta is equal to root 3. And from there, divide by 2, so we see that cosine of theta is equal to the square root of 3 over 2. And now we need to determine all theta values that make cosine of theta equal to the square root of 3 over 2. You may recall from the unit circle that there are 2 points between 0 and 2 pi which do such a thing. One of those is theta is equal to pi over 6. Again, here the cosine of that, which is the x value, is square root of 3 over 2. The other angle here is 11 pi over 6, or the same as negative pi over 6. So our two angles are pi over 6 and 11 pi over 6 if we're bounding our domain between 0 and 2 pi. And both of those would give us cosine of theta is equal to square root of 3 over 2 for those two given thetas. Except we're trying to solve this equation up here for all possible theta. And as it turns out, the way we deal with this is we say 2 pi k plus pi over 6 is a solution. What is this 2 pi k? That, if we look at the unit circle over here, if we start at pi over 6 and then we go around 2 pi, we end up back at the same spot. So again, cosine of that angle would give us root 3 over 2. We can go another 2 pi and we get back at the same spot. We could also subtract 2 pi and get back to the same spot. So we deal with this by saying 2 pi theta is equal to 2 pi k plus pi over 6. And we write that is true for any integer k. And so that could, a positive k value can give us rotations in the positive direction here, which is counterclockwise. And if we have a negative k value, then we can get rotations around this unit circle in the clockwise direction. But either way, this will give us all solutions for pi over 6, but also recall that we had 11 pi over 6 as a possible solution. So we should also write 2 pi k plus 11 pi over 6. And those two infinite sets give us the entire solution, all of the solutions to this equation that we were just given. And that's it for part A. We have two more examples here. We will start with, or go with, 2 sine squared of theta minus 1 is equal to 0 for the next one. So here we see 2 sine squared of theta is equal to 1. Again, we're solving for sine squared, just like we solved for cosine of theta last time. And so sine squared of theta is equal to 1/2. Then if we take the square root of both sides, if we square root both sides here, we get absolute value of sine of theta is equal to 1 over the square root of 2, which is the same as the square root of 2 over 2. And we want to find all values where the absolute value of sine of theta is equal to 1 over root 2. So let's again write down our unit circle. Well, if we plug in pi over 4 sine of theta, pi over 4, not pi over 2. If we plug in pi over 4, sine of theta is root 2 over 2. So that'll be one solution. If we plug in 3 pi over 4, we also get root 2 over 2. If we plug in 5 pi over 4, we get negative root 2 over 2. But again, we want the absolute value of that to be root 2 over 2. So in fact, that is a solution as well. And 7 pi over 4 will be another solution. And these are all between 0 and 2 pi. But again, we can keep rotating by 2 pi on each of these. So our solution is theta is equal to pi over 4 plus pi k. And here I wrote pi k instead of 2 pi k because we start at pi over 4. If we just go pi, we get this solution. Pi again, we get this solution. So we just keep rotating by pi each time to get both of these solutions and all of the solutions that are coterminal with those two. The other one is 3 pi over 4 plus pi k. And again, this is for any integer k. We have one more question here. That is to solve the equation sine squared of theta minus 8 sine theta minus 9 is equal to 0. And to do this, we can recognize that this looks like a quadratic equation, so we can factor. So this is sine of theta plus or minus something times sine of theta plus or minus something is equal to 0. Well, we need this something to multiply to be negative 9 and add to be negative 8. So negative 9 and positive 1 satisfy that. So we get sine of theta is minus 9 is equal to 0, and sine of theta plus 1 is equal to 0. Sine of theta, this left one, implies that sine of theta is 9, except sine of theta is always between negative 1 and 1, so this is not a solution. Oops. So again, sine of theta is between negative 1 and positive 1, always. So sine of theta equal to 9 has no solution. There is no theta value that makes that true. For the other one here, sine of theta plus 1 is equal to 0, this implies that sine of theta is equal to negative 1. Where does that happen? Well, thinking about our unit circle, that should happen at 3 pi over 2. So we, in fact, get the solution. Theta is equal to 3 pi over 2 plus 2 pi k, again, for any integer k. And that's it for the 3 examples I wanted to go through. So that's it for this video.